Hello guys, so right now let's look at this grade 12 term 1 control test for a 2023 March. Ne? So we're going to be dealing with this question paper right now. So I'm just going to browse through the questions that we have here. Okay, let's see. Right, let's look at question 2. I'll just zoom it in so that it can be more visible for you guys. Right, okay, so under question 2, we are dealing with quadratic patterns. You understand? So if you can look at our statement here, they say the first four terms of a quadratic pattern are 11, 20, 30, 33, and 50. So these are the first four terms of our quadratic pattern. And another thing that you must know, in terms of quadratic patterns, ne, a quadratic pattern is just simply a pattern whereby the second difference of the pattern is constant. I'm going to show you what I mean. So we're going to be looking at specifically question 2.1. So for 2.1, they say that we need to determine the general term of this pattern in the form of Tn equals an squared plus bn plus c, right? So basically the general pattern or the general term of a quadratic pattern should look like this. So this is the formula that you're going to be using. Okay, let me write it down. Tn equals an squared, right? Then plus bn plus c. Okay, before we substitute anything into this formula, before we start filling up all that is required, the first thing that we're gonna do, we're gonna need to find the second difference of the pattern. So if our pattern is like this, let me just scroll up a bit. So if this is our pattern, we have 11, right? Then the next term is 20. Then next we have 33. Then next we have 50. Okay, so let's do it like this. We're going to look for the difference between 11 and 20 first. Ne? So to look for the difference, you just say term number 2, subtract the previous term. So we say 20 minus 11. 20 minus 11, it will give us what? It will be 9, right? Then we look for the difference between the next two terms as well. So we say 33 subtract 20. 33 subtract 20 will give us 13. Then we go to the last two terms, which is 33 and 50. Now we're going to say 50 subtract 33. 50 subtract 33 will give us 17. So basically, if you can look at the difference that we got here, 9, 13, and 17, this difference is not constant. So this is just what we call the first difference. But the first difference will not be constant if this is a quadratic pattern. The numbers will be different for the first difference. Ne? And then we have another one that we call the second difference. The second difference is the one that must be the same. That must be constant. So we're going to look for the difference between the two terms. So we say 13 subtract 9 first. So 13 subtract 9 will just give us a 4. Right, then we go to 17 and 13. We do the same thing. We say 17 subtract 13. So 17 subtract 13 there, the answer will be 4 as well. So this is what we call the second difference. So basically, in terms of a quadratic pattern, the second difference is the one that is going to be constant, the one that is going to be the same. You understand? Is the one that is going to be common. But the first difference, the numbers are going to be totally different. So that's in terms of a quadratic pattern. So basically, since we say this is our general term, Tn equals an squared plus bn plus c, right? So firstly, let's start with a. For the value of a, you're just going to do it as simple as this. The value of a is equal to, let me show you. Okay, a basically you just calculate it like this. You're going to take a and times it by 2. So 2 times a will be equal to what? To the second difference. So basically this is just the formula. So basically in terms of everything, every time the a in front of n squared, 2 times a should always be equal to the second difference. So that's how it goes. Ne? So for you to get the second difference, you have to multiply a by 2. So for us to find a, it's just a matter of dividing by 2 on both sides of the equal sign, so that the 2 in front of a can get cancelled, and then we're left with the a that we want. So it's going to be, therefore a is equal to, then 4 divided by 2 is what? Is 2. So our a is 2. That's the first one. So we need to find a, b, and c. Those are the only ones that are required. For n, you don't have to substitute anything for the nth term or for the general term. So we need just the coefficients of the n squared and the n and the constant term of c there. So we already found a. So it means that our general term, we already know that it's going to be Tn is equal to 2 in the place of a, right? Because that's what we found for a there. So it's going to be 2n squared plus bn and then plus c. So basically just goes like this. Okay, then for B and C, what are we gonna do? Okay guys, for B and C, there's no other formula that you can use, whereby like for 2a, you see for that for 2a, I said if you wanna find a like that, you're just gonna take the a times it by 2 and then you equate it to the, it will be equal to the second difference. But for B and C, we can't do it with any other method like that. So what we're just gonna do, we're gonna take the terms from the sequence. Here we have term number 1, which is 11, right? And then here we have term number 2, term number 3, term number 4. You can just take any two of these terms that we have here and substitute them into the general term equation. So we're gonna take either of the any two terms here and substitute them into the equation. So I'll just take term number 1 and term number 2, which are 11 and 20. Okay, so I'm gonna substitute them. So let's start with the first term, which is 11. So it means that I'm gonna write it as okay, wait, I'll just write it here. We're gonna say Tn equals to a is 2. Then in the place of, okay, in the place of Tn, ne, I'm gonna put 11. Ne? I'm not gonna write Tn anymore. Why am I putting 11? Is because we have to substitute some terms in order for us to find B and C. Otherwise, if we don't substitute any of those terms, we might not be able to get to the answer, you see. So in the place of Tn, I'm gonna put 11 because 11 is one of those that we chose that we're gonna substitute into the equation. So it's gonna be 11 equals to 11 in the place of Tn, right? 11 equals to 2n squared. What is n? N is gonna be 1. Why is n 1? It's because 11 is term number 1. You understand? So if in the place of Tn you put 11, then it means that wherever you see n, you're gonna write 1 because 11 is the first term. So it's gonna be 2 1 squared. Instead of n squared, you write 1 squared, then plus b, then it's bn. So we have another n again. I'm gonna put 1 again, then plus c. So it's simple. So we're gonna have, in other words, it's gonna be 11 equals to, then 1 squared here. If you put this on the calculator the way it is, right? 1 squared is 1, then times 2, it will just be 2. So if you put it on the calculator the way it is, it will just give you 2. And then we say plus, then here we have b times 1. B times 1, it will just be b because any number times 1 remains exactly as it is. And then plus c. Okay, then here it's just a matter of adding like terms where it's necessary. So I can take 2 to the other side because it's a like term to 11. But remember, when it goes to the left hand side of the equal sign, when it skips to the other side of the equal sign, its sign must change. So 2, it means that it will become a negative 2 because it's skipping the equal sign. So that's why we need to change the sign of the 2. So it means we're left with b plus c on the right hand side. So 11 minus 2, it will just give us a 9, right? So it's going to be 9 equals to b plus c. Then this is our first equation. We can just make one variable to be on one side alone. Anyone, you can choose between b and c. So I'll just put b on one side, meaning I'll take c to the other side. So it means that here we're going to have 9 minus, the c will become negative when it crosses over because the sign must change. So it will be 9 minus c then equals to b. So you just put one variable on one side by itself. So this will be what we call the first equation. So this is kind of like simultaneous equations, you see. So we substituted with term number 1. Then let's go back. We're supposed to substitute with 2 terms, ne? The second term that we're going to choose is 20. So it's term number 2. Then I'm going to substitute it into the equation as well. Okay, so it means it's going to be, in the place of Tn, I write what? I write 20 because term number 2 is 20, right? That's the one that I'm substituting now. So it's going to be 20 equals to 2n squared. So this time in the place of n, we are going to have 2. Why are we writing 2 in the place of n this time? Is because 20 is term number 2. Remember, for 11, we wrote 1 in the place of n because 11 is the first term. So this one, 20, is the second term. So I put 2 in the place of n, and then I say plus b, then it's bn, right? So in the place of n, I put another 2 again, then plus c. So it means, in other words, it will go like this: 20 equals to, then you put this on the calculator. Some others you just put them on the calculator just to simplify things for yourself, ne? So 2, when you put it on the calculator, 2 squared is 4, then 4 times 2 is 8. So when you put it on the calculator, you'll get 8. Plus b times 2 is just 2b, then plus c. Right. Okay, so we do the same thing, putting the like terms on one side. So 8, we can bring it to this side, and remember, the sign of 8 will become a negative because it's crossing over. So the crossing over the equal sign. Then equal to, on this side, we're left with 2b plus c. Remember, for the first, when we were substituting with 11, I said you're going to have to leave one variable on one side alone, ne? But for this one, you don't have to do it. As long as you did it with the first equation, you don't have to do it again, ne? So 20 minus 8, we just subtract them like that. It's going to give give us 12 then equals to 2b plus c. Then 2b plus c here, we can leave it like this. We don't have to take one variable to become on one side. It's not necessary. As long as you did it with one of the equations, it's enough. You don't have to do it twice, you see. So this one will be the second equation, the one where we substituted with 20. So we have equation 1 and equation 2, right? Let's go back to equation 1 and let's identify something. Here, equation 1, it actually shows that b is equal to 9 minus c, right? So it's 9 minus c equals to b. 9 minus c equals to b just means that b is equal to 9 minus c. I can write it like that. B is equal to 9 minus c. So this is equation 1. So the reason why I'm showing you equation 1 is because if equation 1, it shows us that b is equal to 9 minus c, right? It means that in the place of b, wherever I see b, I can just write 9 minus c instead. Why? Because they are equal. So if they are equal, it means that it's the same thing. Whether I write b, whether I write 9 minus c, is the same thing. So in the place of b, I can just put 9 minus c if I want, because they are equal. So that's what I want us to do in equation 2 here. I'm going to write 12 equals to 2, right? Then in equation 2, we have 2b plus c. In the place of b here, I want to write 9 minus c, because b is equal to 9 minus c. That's why I wanted to put b on one side alone, because I wanted us to actually have another value that we can substitute instead of b. You see, because when it's like this, do you see that now we have only one variable inside the equation? It's only c. It's no longer b and c, and that way you can actually solve it. So the purpose for this is so that we can actually have one variable in the same equation, not two different variables in one equation. You understand? So in the place of b here, I put 9 minus c because that's what b is equal to. Then I can just simplify here. So it's going to be 12 equals to, then I multiply 2 into the bracket. So it's going to be 2 times 9 and 2 times negative c. So first of all, 2 times 9 is 9, 18. So it's going to be 18. Then 2 times negative c is going to be negative 2c, right? So 2 is positive. So if I say positive times the negative for c, it's going to give us a negative sign since the signs are different. Oh, sorry, I wrote x, supposed to be c. So it's 2 times negative c, so it's going to be negative 2c, then plus c. So basically, when you do it like this, it becomes so much easier. Then we can take 18 to the other side, because it's a constant. Or wait, let me not take 18. Let me do it like this. I'll take the ones just c, I'll take them to the left. So I take negative 2c, I bring it to this side, it becomes a positive 2c. If it's negative, when you take it to the other side, it becomes positive. If it's positive, when you take it to the other side, it becomes negative. So negative 2c is negative on the right. So when it goes to the left, the sign changes to positive. Then I'm also going to take positive c here and bring it to this side, but it's going to be negative this one because it was positive on the right. So I bring the 2c's to one side. Then here we're left with 18, right? Then it means that 12, I can just transfer to the right, then it becomes a negative 12. The sign will change as well. So 18 is the only one that I didn't change the sign for, because 18 didn't move. It's still on the same side, you see. So 2c minus 2c. Okay, one thing that you must know about this c, this one, the one that is just sitting by itself, you must know that the coefficient or the number in front of the c is 1, because they didn't write any number. As long as the number is not written, the coefficient is not written in front of the variable, it means that the coefficient is 1. So 1 is in front of c because they didn't write any number, so it's 1. So we're going to say 2 minus 1. 2 minus 1 is what? 2 minus 1 is 1. So it means that the answer is 1c. But remember, in terms of mathematical terms and mathematical language, in front you don't have to write 1c. You just write c. Because even for the negative c there, they didn't write the one in front. I'm just the one who highlighted it so that no one gets confused when I'm doing the calculations. Okay, now we have 18 subtract 12. So 18 subtract 12, it means we're going to be left with 6. So this is the value for c. C is equal to 6. Then what is b going to be? In b, we already said is equal to 9 minus c, remember. B is equal to 9 minus c, but we cannot have 9 minus c as the answer. We need to have a real number, like an actual, just a number, like c. For example, c, we say it's equal to c. That's a number, you see. So for this one, we can say 9 minus, then in the place of c, we put 6, because c is equal to what? C is equal to 6, like they show us here. So we can solve for b like that. Since it still has the variable here, c, we just need a number. So 9 minus 6 is going to be 3. So b is equal to 3, c is equal to 6. Done. Simple. So you can just rewrite the general term and say tn squared is equal to, oh sorry, not tn squared, is tn. Excuse me, I apologize. So it's tn is equal to 2 n squared, right? Now we are no longer substituting anything in the place of tn and n because we already found our answers now. Then we say plus in the place of b, it's bn. So I'm going to write 3n because b is 3. Then lastly, plus c. C is what? We said is equal to 6. Then you are done. This is your general term. Finished. Simple. You see it, guys. So yeah, basically in terms of the general term of a quadratic pattern, you can just calculate it like this. So all you have to remember is that a quadratic pattern has two differences, right? And then to find a, you just have to times a by 2 and equate it to the difference, whatever the difference is, the second difference, not the first one. Then you'll be done. Oh well, you'll not be done. You still have to find c and b. Then after you find those two, then that's all. Okay, thank you so much for your time, guys. I really hope that you enjoyed the video, and if you did, please like and subscribe to my channel for more videos, right? Then that's all for today. And another thing, if you're interested in joining my math classes, you want to improve your math skills, just contact me on 081-703-1197, and my group sessions are just 300 rands per month. Okay, thank you so much, guys. Bye.